Welcome to solverfy.
Hi everyone, today we're going to solve problem 24 of chapter 2 of the 8th edition of Survey and Jet. So the question is asking us to find the minimum amount of time t it takes for the fighter jet landing on an aircraft carrier to come to a complete stop. So what this tells us immediately is that the final velocity of the plane is going to be 0 meters per second. And we're also told that when the fighter jet lands, it has an initial velocity of 100 meters per second. And we're also told that it can apply its brakes at most efficiently enough to get a deceleration of 5 meters per second squared. Now this is deceleration, so the acceleration is happening against the direction of motion, which is why we pick up this minus sign in the acceleration. Now to find the time it takes for the plane to come to a stop, we can use the formula for the final velocity under acceleration, which is the final velocity is equal to VI, the initial velocity, plus the velocity gained through acceleration. And so what we're interested in is this variable t. And so to rearrange for that, we subtract VI from both sides, and we divide by the acceleration A. And so that's how we get t. And now we have all the values for these symbols on the right. So we know what the initial final velocities are and what the acceleration is. So substituting that in, we have 0 minus 100 meters per second divided by minus 5 meters per second squared is equal to 20 seconds. And so the fighter jet takes 20 seconds to come to a full stop on the aircraft carrier. So now we're going to solve problem B and C in one. And so this is asking us whether this fighter jet can stop on a tropical island that has a runway of 800 meters, which is represented on this number line over here on the right. So what we know now is that the initial velocity is 100 meters per second. We know that the acceleration is again minus 5 meters per second squared because it's decelerating. And we also know that the motion is taking 20 seconds. And so the distance that the plane travels in this time is going to be the distance it would travel if it was traveling with a constant velocity, plus the distance that it travels under acceleration, which is given by half a times t squared. And so again, we know what VI is, we know what t is, we know what a is, and we know what t squared is also. So what we do is we just plug in the values that we have over here. So we have 100 times 20 plus 1 over 2 times, and now we're going to use minus 5 again because the plane is decelerating as opposed to accelerating, and then times 20 seconds squared. Now this is just a simple calculation, so we're going to have 2,000 meters minus 20 squared is 400 divided by 2 times 5 meters per second squared, and this works out to be 1,000 meters. And so this is the distance that the plane travels as it comes to a complete stop, which we can see is much greater. It's 200 meters greater than 800 meters. And so equivalently, we can say that D is greater than L, which means that the jet can't stop on this runway. So it can't